Hello, in this video we're going to look at three measures of consumer welfare from a price change. We're going to use a quasi-linear utility function as our example. So the goal here is to solve for the effect of a price change on consumer welfare using three different methods. The first method, and most common, would be consumer surplus, the dollar difference between the maximum amount that a consumer is willing to pay for a quantity of the good and the actual market expenditure made by the consumer. This is easy to calculate from ordinary or uncompensated demands. One problem, however, it does not hold utility constant when analyzing the effect of a price change on consumer welfare. A price change along an ordinary demand includes both a substitution effect and an income effect. Compensating variation, another measure of consumer welfare we can look at, holds utility constant. This is the amount of money a consumer needs to be compensated so that a price increase is not harmful. How to calculate? We're going to maximize utility at the original prices, that is before the price increase, using the consumer's income, and then we're going to solve for the utility level at the original prices and the consumer's initial income level. In step 2, we're going to solve for the level of income necessary with the new prices, for example, a higher price for good X, to get the same level of utility in step 1. Way to think about this is that we're minimizing expenditures subject to a fixed level of utility that we established in step 1. The difference in the income levels between step 1 and step 2 is the compensating variation. The equivalent variation is another measure of consumer welfare from a price change that also holds utility constant. It's the amount of money a consumer would be willing to give up in order to not face the price increase. How to calculate? Step 1, we're going to maximize utility at the new prices, that is at the higher price for good X, using the consumer's original income, and then we're going to solve for the utility level. In step 2, we're going to solve for the level of income necessary with the original prices, that is before the price increase, to get the same level of utility in step 1. Once again, we can kind of think of this as minimizing expenditures subject to the fixed level of utility that was established in step 1. The difference in the income levels between step 1 and step 2 is equivalent variation. With a normal good, the welfare effect of a price change is going to be the following. Ignoring the minus signs, putting everything in absolute value. Compensating variation will exceed the change in consumer surplus, which will exceed the change in the equivalent variation. So compensating variation, here we have the change in consumer surplus, and here we have the equivalent variation. A good with no income effect, that would come from a quasi-linear utility function that we're going to use just in a moment. The welfare effect of the price change is that all three measures give us the same exact value. And with an inferior good, we're going to just flip these inequality signs. The good news is that for a small change in price, all three measures of consumer welfare are going to be very similar. So I suppose this would be an argument for just using consumer surplus. Ordinary demands and uncompensated demands are easier to estimate. So let's start with calculating the compensating variation from a price increase. Here is the consumer's utility function. It's quasi-linear. We have a consumer with $10 of income, the price of good X, the original price of good X is $1, and the price of good Y is $2. We're going to eventually have the price of good X increase to $2, and we'll see what the compensating variation would be, equivalent variation, and then the change in consumer surplus. The budget constraint, given this income of $10 and these original prices, income equals the price of good X times X. Since the price of good X is 1, I'm just going to write X. Price of good Y is 2, so it's 2 times Y. So we're going to maximize utility here, getting the marginal utility of good X. We get this result right here. Getting the, and just simplifying 1/2 times 2. That cancels. And getting the marginal utility of good Y, it's just going to be 1. Setting up our utility maximizing condition. So I'm just going to take the marginal utility per dollar for each good and set that equal across both goods. So the marginal utility of good X divided by the price of good X, marginal utility of good Y divided by the price of good Y. Again, price of good X is $1, price of good Y is 2, and we're going to solve this for X. So following the rules of exponents, moving that X to the minus 1/2 down in the denominator, we're going to get X equals 4. So here's again our original budget constraint, and if X equals 4, I'm going to plug that into the budget constraint, solve for Y. Y will equal 3. Calculating the level of utility when X equals 4 and Y equals 3. We're going to get utility equals 7. All right, now let's look at the increase in the price of good X to $2. Again, we're going to eventually come to the compensating variation. So price of good X increases from $1 to $2. Setting up our utility maximizing condition again, but now putting in our new prices. Price of good X is no longer 1, it's $2. Price of good Y is still $2. Marginal utility of good X, marginal utility of good Y given in the numerators. We're going to solve for X, and here we're going to get X equals 1. We're going to plug this X equals 1 into the utility function, but this time when the utility function equals 7. So holding utility fixed at 7, and if X equals 1, Y would equal 5. The cost of the basket at the new prices, price of good X is 2, price of good Y is 2. Plugging in X equals 1 and Y equals 5 into that, we get an income of $12. So to get the same level of utility before the price increase, the consumer would need $12 of income to be would need $12 of income with the price increase. So the difference between $12 and the old income of $10 is the compensating variation. So 12 minus 10 is $2. The amount of income that fully compensates the consumer for the price increase. In terms of consumer welfare, the price increase made the consumer worse off by $2. All right, let's move on to the equivalent variation. Moving on to the equivalent variation, the amount of income taken that would harm the consumer just as much as the price increase. We're going to find the utility with the price increase. And again, that's when the price of good X goes from $1 to $2. So we're going to maximize utility. We already have all these things, marginal utility of good X, marginal utility of good Y. So plugging those in the numerators and then putting in our respective prices. Again, price of good Y always stays constant at 2 here. Solving for X, X equals 1. Plugging that into our budget constraint. Again, with the new prices, consumer has income of $10. So doing that over here, if X equals 1, Y would equal 4, and the level of utility when X equals 1 and Y equals 4 would be 6. So our next step is to find the level of consumption at U equals 6, but at the original prices. So price of good X originally is $1. Setting up the utility maximizing condition. Solving for X, X equals 4. Taking this X equals 4 and plugging into the utility function where U equals 6. And solving for Y, Y equals 2. What is the cost of this basket when X equals 4 and Y equals 2? It is $8. So with an income of $8, a consumer's utility at the original prices is equivalent to the utility with an income of $10 at the higher price for good X, at the new prices. This difference between the $10 and $8 is the equivalent variation, or $2. So taking $2 of the consumer's income is as harmful as a consumer facing the higher price of good X. In terms of consumer welfare, the price increase made the consumer worse off by $2. Now let's look at the change in consumer surplus, another measure of consumer welfare. So first we're going to solve for the demand for good X, setting up the utility maximizing condition and solving for X. Here we have just the ordinary demand, uncompensated demand, Marshallian demand for good X. And since price of good Y is 2, making that substitution, here is our ordinary demand. So if the price of good X rises from $1 to $2, let's calculate the change in consumer surplus. So we're just going to use a little integral calculus here. Plugging in our values for the price of good X, $2 and $1 here, we get a change in consumer surplus. Since the price went up, it's negative, so we get a change here of minus $2. So all three measures of consumer welfare give a $2 welfare loss because of the price increase. Okay, that's it. I hope you found this video helpful.